Hello guys, welcome to today's leetcode challenge. Today we're going to solve this maximum number of k sum pairs. You are given an integer array nums and an integer k. In one operation you can pick two numbers from the array whose sum equals k and remove them from the array. You are asked to return the maximum number of operations you can perform on the array. Okay, so this is an example. You're given 1, 2, 3, 4 and k is 5. You are supposed to return 2, and the explanation states that if I stick 1 plus 4, I can get 5. So that's the first operation. And also if I pick 2 and 3, they sum up to 5. That's the second operation. So this one should not be repeating, as they have said that you should be removing the values from the array each time you pick. Okay, so the second example, we have 3, 1, 3, 4, 3. So 3 plus 3 equals to 6. But then results, remember we have also another 3, but since we were removing these values from the array, it means that we only have 3, 1 and 4. So in that case we just return 1 because it's only one operation, 3 and 3, that resulted to 6. Okay, so how can I solve this? Let me go back here and me zoom it a little bit. I don't know if I can zoom it. Oh, I cannot zoom. Okay, but my idea is to the easiest way is to loop through the elements while storing its complement. So for example, I'll loop through all the elements while storing the complement of 1, which is 5 minus 1, which is 4. Then while traversing through the array, I will try to see if I can find this value or that complement, or if I can find the complement of a number in the where I'm storing, right? I'll be storing the complement maybe in a hash map or somewhere where now while traversing through the elements, if I find that complement inside there, it means we are able to the two numbers can be summed up to the resulting k, and that is one operation. Then after that we'll maybe reduce the count of the number or something. So I will do this. So first I will set the count to be 0. This will be tracking the number of operations that we have done, and after that we will need to define a hash map, and I will name it, how should I name, frequencies or something like this. And after that I will be looping through the elements in the array. So I will say for num in nums, right? And I'll define a complement here is equals to k minus num. So I will say if complement in frequency and frequency complement is greater than 0. So why are we tracking the values in the complement is for our case here, when we have in this case we'll have like 3 complements here that are equal. This one 3, 3, 3. So in that case we need to know the number of elements that we're going to remove from the array. So that's why we are tracking the count. So if the value is in the complement and the complement and the value is greater than 0, so we need to increment the count by 1 because we have found a match, and also we need to decrement the value in the frequent complement by 1. Just like for our case here, we just need to decrement it. Else, if it's not found there, it might be already deleted. So we need to make sure that you are checking this. If complement in frequency, then it means the complement is at 0, right? So in that case we just need to set the frequency to 1. Else we just need to set it, okay, I can do this, plus is equals to 1. Else we can just set the complement to 1. Yeah, just that way, and then we can return the count. So if I run the program, oh, wrong answer. What am I doing wrong here? So count plus is equals to 1. Now we shouldn't, in the else statement, we should compare if the num is the one in frequencies. If it's not there, we need to add the value num. Yeah, because if you are checking the complement, we need to, and we are comparing if the complement is in frequency, then if it's not there, we should add the value num there. Yeah, this is what I was missing. So if I run now the code, where do I run it? I don't know. Should I refresh? Okay, run. Yeah, if now I run the code, you can see it is working. So the issue is you have to, if the complement of that number is not there, then add that number inside there, so that when we go to the next value and we find we are looking for the complement, we can track back the number. Yeah, so that is it, guys. Thank you. And if I submit here, yeah, you can see it beats 67% in time complexity.